And good morning, everybody. Here are your notes and examples for IXL.com, Algebra 1, module KK.7, and it's going to be on standard deviation. And before we do any problems, let's go ahead and first talk about standard deviation. So standard deviation basically will measure how much the data values deviate or stray from the center of the data. So for example, if you had a data set, maybe you had a minimum number and a maximum number, and then you had all your numbers in between. So let's say these x's are kind of representing your data values. And let's say you added up all these data points and you found the mean, so the center point, the balancing point. Then someone might ask, on average, how far away are the data values from the actual center of the data? And that is going to be what the standard deviation is measuring. So in this particular case, it doesn't look like there's any real data values that are actually at the value of the mean. You have some that are less than the mean and some that are more than the mean, but there don't seem to be any that are really right around where the mean is, as opposed to maybe a different data set. And let's say we had our mean calculated. So let's say this was our center. And maybe we had our data points all kind of hovered right around the actual mean of the data. So this would be something where it would not have a lot of standard deviation. So the data points don't deviate from the center very much. They're all kind of centered right about where the mean actually is where most of your data is, as opposed to this one, your mean is here, but your data deviates or is not really close to the mean. So we're going to be coming up with a way to measure on average how far away are the data points from the mean. So that's basically what your standard deviation is telling you. On average, how far away are those data points from the actual center of the data? And to do this, what we're going to need to do is we're going to need to find the mean, and then we're going to need to find the difference between each data point and the mean, and then make sure everything is positive, and then find the average of that new number. So for my students, what I did is I created a chart for you. So when you go through these IXL problems, you can use this chart or you can just recreate it on another piece of notebook paper, just to kind of track your calculations. So in the chart, you're going to have your original data set, and then you're going to subtract each data value from the mean to see how far away it is. Sometimes you're going to get positive numbers, sometimes you're going to get negative numbers. So to make sure everything is positive, what you're going to do is square all those values, all these differences that you find, you're going to square them, which will force everything to be positive. And then if you find the mean of this new data set in column 3, that's going to be what they call the variance. So if you find your new mean of all these squared differences, you're going to get the variance. However, this number is going to be larger than the actual original numbers in the data set because we squared everything. So to get it back to, or to undo the fact that we squared everything, we're going to square root everything. And that's going to be what we call our standard deviation. IXL will ask you one of two questions. It will ask you, on some problems, it will ask you what is the variance, and on other problems it will ask you what is the standard deviation. So you just need to kind of watch out for which one it's asking you. The symbol that they use for variance is going to be a lowercase sigma, so that's going to be sigma squared, that's the variance, or sigma is the standard deviation. And let's go ahead and try one from the iexcel.com. So here's your data set. Notice on this one they want the variance. So we're not going to go through that last final step and square root the number to get the standard deviation. We're just going to stop at the mean of the square of the differences. So let's go ahead and put this data set into the chart. Again, if you don't have the chart printed off, you can do it on pretty much any piece of notebook paper. It's just kind of good to kind of organize your steps. So let's go ahead and put this into the chart. So here's our numbers typed into the chart. So we have 216, 3135. That was the original data set. And then the first thing you want to do is just find the center. So what was the mean? So you want to add those all up and divide by how many there are. So if we add these all up, we should get 21. And how many data values are there? There are 7, so we're going to divide by 7 and get something out of that. So 21 divided by 7 should get us 3, so that is going to be our mean, our x bar. So x bar represents the mean. And then we need to find how far each data point is away from the mean. So if we look at this first data point, 2, we're going to do 2 minus the mean. So it's going to be the 2 that we have minus the mean, and we said our mean was 3. So if we do 2 minus 3, then we should get -1. And then if we do the next one, it's going to be a data point of 1 minus the mean, and 1 minus the 3 should get us -2. And then 6 is our next data point, minus the mean. So 6 minus 3 should get us 3. Notice some are working out to be positive and some are working out to be negative. This is why we're going to square everything. The next one, the data point was 3, minus the mean, which was 3. So that one was right at the mean, so that one does not deviate very much. It had a difference of 0. It did not change anywhere from the mean. The next one is a 1 minus 3, which is -2. And then we have 3 minus 3 again, which is 0. And then 5 minus the 3, which is 2. So that's going to be all of our differences between the data point and the mean. So that's how far away they are and in what direction. So the negative would tell you which direction it is, whether it's above the mean or below the mean. And since we're going to be averaging these numbers, we don't want them negative, so we need to do something that's going to make them positive. So what we're going to do is we're going to square them all, because when you do a negative times a negative, it will make it positive. So on the first one, if we do the -1 squared, -1 times -1 should get you 1. The second one, -2. So if we do -2 squared, -2 times -2 is 4. And then the next one we'll do 3 squared, which is 9. And then 0 squared, which is 0. -2 squared, which is 4. 0 squared, which is 0. And then 2 squared should get us 4 again. And that is all the squares of the differences between the data point and the mean. And then the next thing you want to do is you want to find the new average, the new mean of all these new numbers. So add these all up and divide by how many there are. So if we do 1 plus 4 plus 9 plus 0 plus 4 plus 0 plus 4, you should get 22. Clean that up a little bit. So 22 divided by, there's 7 values. So 22 divided by 7 should get you approximately 3.1. IXL is going to ask you to round to the nearest 1 decimal place. So that should get us about 3.1. That is going to be the variance, 3.1. And that is what IXL is asking for on this particular problem. Some of the problems will ask you to go that one additional step and find the standard deviation. So to find that, you're going to square root the 3.1 to undo the fact that everything was made larger by the squaring process. So for the standard deviation, you're going to square root this number. Make sure you hang on to all the decimal places. This was actually a number that had more decimal places than about 3.1. It was actually something very close to pi, 3.14. So make sure you square root everything when you do that on your calculator. So for example, if you had the 22 over 7, hanging on to more decimal places, it was 3.14, 228, 57, 143. And if you square root that, you should get approximately 1.8. So some problems on IXL will ask you for this actual standard deviation. For this particular problem, they wanted the variance, which was 3.1. So in your answer box back here, you just want to put in the variance was 3.1. So there's our variance. This is a standard deviation. So what is this number really telling us? It's saying that on average, these data points, on average, were about 1.8 away from the mean. The mean was 3. So on average, it could be 1.8 more than 3 or 1.8 less than 3. On average, they're about 1.3 away from the center of that data. But let's go ahead and do another problem that has standard deviation. So here's our next data set. This one, they want the standard deviation. So we're going to take that square root number. And let's go put our data into the table. So our data points, we should have 3, 2, 5, 217, and 8. So there's our data points. The first thing we want to do is find the mean, so add these up. So if you add these up, you should get 28. Divided by, there's 7 data points, so divide by 7, and we should get 4. So our mean, our x bar, is 4. And then we want to find the difference between the data point and the mean. So the first one, it's going to be 3 minus the mean, which is 4, which should get us -1. And the next data point, 2, minus the mean, which should get us -2. And then 5 minus the mean, which should get us 1. And then 2 minus the mean, which should be -2. And then 1 minus the mean, which is -3. And then 7 minus the mean, which is 3. And then 8 minus the mean, which is 4. And then we want to square all these numbers to make them positive. So -1 squared should get you 1. Negative 2 squared, negative 2 times negative 2 is 4. 1 squared is 1. Negative 2 squared is 4. Negative 3 squared, negative 3 times negative 3 is 9. Positive 3 squared is also 9. And then the 4 squared should get you 16. And then you want to find the average or the mean of these new squared numbers. So add those up. If we add those up, we should get 44. Divided by, there's 7 data points. And that is going to be approximately 6.28. And I'm going to run out of room, so let's just put this over here. Make sure you hang on to all the decimal places you can. So this is going to be about 6.285714286 is what my calculator has given you. So that's going to be your 44 divided by 7. So if you do 44 divided by 7 on a calculator, you should get roughly this number, and then that whole number you want to square root that. So you want to square root this answer right here. So we're going to take the square root of 6.285714286. The more decimal places you can hang on to in your calculator, the better. And if we do that, we should get approximately 2.5. And again, IXL wants you to round off to 1 decimal place. So to 1 decimal place, your standard deviation would be 2.5. So on average, your data points, your original data points, on average, these data points were about 2.5 off of the mean. So if you wanted to kind of look at that as a visual, so we had said our mean was, make some room here, we had said our mean was 4. So for this particular data set that we just did, the mean was at 4, the center. And we're saying that off of the mean, on average, your data points are either 2.5 to the right or 2.5 to the left. Not all of them are 2.5, but on average they're about 2.5 away from the center of that data. And let's go back to the problem and put our answer in. So here's our standard deviation. So just go back to IXL. They wanted standard deviation, so it's going to be 2.5 for an answer. And that is it for standard deviation. So you can rewatch or pause those examples. That's kind of the only 2 examples they give you in the IXL.com. You're either looking for that variance, which is just the number prior to square rooting to get the standard deviation, or they're asking you for the standard deviation. And you can make a chart. You can either print off the chart that's in your Google Classroom, or you can just use some notebook paper and make the chart and keep track of your numbers that way.